Hey everybody, we are in section 1.5 and we are going to get started with this next section. We're going to describe angle pair relationships. Please get started by writing this down, write down today's date, and we're going to get started with some vocabulary. So this first word is complementary angles, and basically what complementary angles are two angles that add up to 90 degrees. So complementary angles are two angles, only two, whose measures are going to add up to 90 degrees. So what that's going to look like, go ahead and make sure you have some space so you can draw this picture. So let's say I have these two angles, angle CBD and angle QTP, and their measures are given right there. So the measure of CBD is 42 and the measure of QTP is 48 degrees. If I have two angles such that when I add up their angle measures, I get 90 degrees, like I do in this case, I can say that these two angles are complementary. Our next word is supplementary angles, and these angles are angles such that when you add them up, two angles again, but when you add them up, their sum is going to be 180 degrees. So again, we got those supplementary angles. We know that both of those angles are going to add up to 180 degrees. And if you remember, 180 degrees is a special type of angle, right? Because it's a straight angle. So basically, when we have supplementary angles, those two angles will add up to a straight line. We'll look at this a little bit later. So if we have the measure of angle RAP equaling, let me write my angle in there, equaling 60 degrees, and then the measure of this other angle, HOP, I used P twice, I shouldn't have, but that's all right. The measure of angle HOP being 120 degrees, we can add those together, we get 180, and so we know that these two angles are indeed supplementary. So our next word is adjacent angles, and what that's going to refer to is the positioning of angles. So adjacent angles, right, would be angles that kind of share a side. They have a common ray. They also have a common vertex. So right here, we have adjacent angles. This would be a great example of adjacent angles that are complementary because I can see that when I add them up, I get 90 degrees. So these are adjacent complementary angles. Here are adjacent supplementary angles. Notice that these two angles come together and they are forming 180 degrees. So kind of like a straight angle. We'll talk about that in a minute. And so what we have here would be examples of adjacent and non-adjacent angles. Get that down. I'll write down a little definition for you real quick. So again, when we're talking about adjacent angles, there are two angles that share a vertex, right, and a side, but have no common interior points. So I want you to keep that in mind. So the no common interior points is what kind of gets kids. So if I were to make this angle here, and then make this other angle, let me use a different color, make this angle right here, these two angles are not considered adjacent because they share interior points. Like this point is inside the purple angle and the pink one. So when we have adjacent angles, they're going to be kind of side by side. That's what they're referring to there. Let's go on to another word. So this next phrase is linear pair, and what a linear pair is when you have two adjacent angles with uncommon sides being opposite rays. I know that sounds like a whole lot. Let's see if we can get into what this looks like. Angle 1 and this angle 2. Basically, angle 1 and angle 2 are linear pairs because their non-common side, this is their common side, but their non-common side forms opposite rays or a straight line. You should also by now really think about this as a pair of angles that are supplementary, right? Because you can see that they're going to form a 180 degree angle. So linear pairs are supplementary, but they're adjacent, and that's enough. I think that's what you need to know. So our final word is vertical angles, and here's the picture. This picture really tells it all. Vertical angles are angles where two lines intersect and they create opposite pairs of angles that are called vertical angles. Vertical angles are created by two lines intersecting and the angle across from the other angle, or I would say the non-adjacent angle pairs, are going to be vertical angles. Let's write that down. So vertical angles are angle pairs created when two lines intersect Vertical angles are the non-adjacent pairs. So the pairs of angles that are not directly across from, that are directly across from each other and not directly touching each other, those are vertical angles. Let's get started on our examples. So let's look at example 1 together. Example 1 says that in the figure we're to name a pair of complementary angles. If you remember, complementary angles, those are angles that add up to 90 degrees. Supplementary angles, those are angles that add up to 180 degrees. That's what I'm keeping in my mind. And then adjacent angles, in a way, those are angles that are touching side by side, right? So they're touching. They're side by side. Okay, so now that I've got that out of the way, in order to have 90-degree angle, I know that the angles must add up to 90 degrees. And 122 is way too big to add up to 90 degrees with anything. So I'm going to look at these two. Since 32 plus 58 do add up to 90 degrees, right? Then I can say that this angle is complementary to this angle. So I'll write that out. So angle CAB and angle RST, those angles are complementary. Looking again at these angles, 122 plus 32 isn't going to give me 180, but it looks like 122 plus 58 will. So with some quick addition over the side, 8 plus 2, and then I'm going to get 8 here and 1. Yep, 180 degrees it is. Therefore, this angle, angle CAD and angle RST are indeed supplementary. Finally, we're asked about adjacent angles, and I think you guys can recognize that adjacent angles are kind of stuck together, and so the only two adjacent angles that we have here would be these two right here, angles BAC and angle CAD. So angles BAC and CAD are adjacent angles. Let's go ahead and pay attention to example 2. Find the measures of complementary and supplementary angles. So given that angle 1 is a complement to angle 2, these guys are complementary to one another. Remember, complementary is 90 degrees they add up to. Figure out what angle 2 is if angle 1 is 98 degrees. So if I know these two add up to 90 degrees, I can find the other one. Let's see how we'll do it. First things first, the measure of angle 1 plus the measure of angle 2 must be 90. That's the definition of what it means to be complementary. Next, I'm going to rewrite it with the given information. Since the measure of angle 1 is told to me to be 68 degrees, then I could rewrite this as 68 plus the measure of angle 2 is equal to 90. And of course, you know what we can do here. We would solve this as we solve any equation. We're looking for the measurement of angle 2. So I'm going to isolate what I'm looking for, right? And then when I do that, I get that the measure of angle 2 is equal to 90 minus 68, which is 22 degrees. Similarly for this one, except we're talking about supplementary, which is a 180 degrees, we need to recognize that given the measure of angle 3 and 4 are supplementary, it means that the measure of angle 3 plus the measure of angle 4, they have to add up to 180 degrees. Let's treat this problem the way we treated the last one by substituting in what we know. We're looking for the measure of angle 3, but we do know the measure of angle 4, which is 56 degrees. They both should still add up to 180. I'm going to solve it like I solve any equation. I'm going to isolate what I'm looking for. So that means getting rid of the 56 on both sides. When I do that, the measure of angle 3 is equal to, this is a 56, not a 50, is equal to 124 degrees. And that's my final answer, all right? So when we're looking for complementary and supplementary angles, we need to make sure we remember what those words refer to and what they should add up to. Here in example 3, we're going to talk about finding an angle measure. When viewed from the side, this ball return net forms supplementary angles with the ground. So we're going to find the measure of angle BCE and the measure of angle ECD given this information. I want you to look carefully at this. The first thing that we should observe is that these two angles are supplementary, and therefore we know that this angle plus this angle must add up to 180. So I'm going to write that down. So let me go ahead and do that. All right, so the measure of these two angles, BCE and ECD, have to add up to 180. So now I'm going to do some replacement. So BCE is said to be equal to 4x plus 8, and then ECD is said to be equal to x plus 2, and all of that must equal 180. Why? Because they're supplementary, right? So we're going to join like terms together on the left side, simplify our situation. So I get 5x plus 10 is equal to 180. Now I'm going to isolate that 5x by subtracting 10 from both sides. I get 5x is equal to 170. Now this is just a matter of dividing. Divide both sides by 5. I'm almost done here. 5 goes into that, 3, 2, 4, 34 times. So x is equal to 34. But that's not what they asked us to find. They said, please find the measure of these two angles. So here's the thing. I can plug x value into either of these, or into one or to both of them to figure out the value. But what I could also do is find the easiest angle to find. Since this is x plus 2, which is x plus 34 plus 2, that's easy. I know that that angle over here must be 36. Are you with me? I just added the 2 in there. So remember that the measure of ECB was equal to x plus 2. When I replace x with 34, I get that the measure is 36 degrees. So that's 36 degrees, right? So here's the thing though. Instead of plugging the 34 in, multiplying by 4 and adding and doing the thing, I know that these two angles are supplementary. I know that. So in order to find the measure of BCE, this angle over here, watch, I'm simply going to take 180 and subtract 36. When I do that, I get that this angle has to be equal to 144 degrees. And so that was a little bit easier to do. Did that make sense? If you felt uncomfortable, please feel free to plug the 34 into the 4x plus 8 and solve it that way. So in this example 4, we're going to look for all the linear pairs, and I'm going to mark them off. I know that 4 and 5 are linear pairs because they make a straight line. And 1 and 4 are linear pairs because they make a straight line. So I'm going to write those linear pairs down. So those are my linear pairs. Now we're going to look for vertical angles. Vertical angles, remember, are angles that are created by the intersection of two lines. These guys are vertical. These pair are vertical. They're kind of across the street. Sometimes I call them bow tie angles because they look like a bow tie. Okay, so let's go ahead and see if we can find some. When I look here at this intersection and this intersection, I see that angle 1 and angle 5. You guys see that? Angle 1 and angle 5, those are vertical angles. If you can see some more, let me know, because I don't know if I'm seeing any more. I'm looking carefully. Those are the only two lines that are intersecting. This is a ray, doesn't really have a pair. 4 is not really vertical. It's kind of vertical to 2, 3, but they're not a pair because it's a couple. So I'm going to just stop at this. Our vertical angles are 1 and 5, and our linear pairs are 1 and 4 and 4 and 5. This is our final example, and this is one you will see again because that's how life is. So make sure it makes sense. Two angles form a linear pair. Picture it in your head. Got it. The measure of one angle is 5 times the measure of the other. Find the measure of each angle. All right, this is kind of hard, but I think we can do it. Let's kind of draw a picture so we can kind of imagine what's going on. So here's a linear pair, and let's call this angle X, and let's call this one Y. And so I have one being bigger than the other one, right? So let's see what we can think about this. Two angles form a linear pair. I'm going to call it X and Y. That's their degree measure, let's pretend. The measure of one angle is 5 times the measure of the other. So that looks like the Y angle is 5 times this one. So I'm going to write it down. Y is going to be equal to 5 X's. Does that make sense? All right, hold on. Now they're asking find the measure of each angle. What are we going to do? We're told that they are linear pairs, so I know that when I add them together, I get 180. So I know that X plus Y has to equal to 180 degrees. But here's something cool. If Y is equal to 5 X's, that means I can replace Y with 5X. Why is that helpful? It's so much easier solving an equation with one variable than solving it with two. So I just made my life so much easier. Let's go ahead and solve this equation. If I've got an x here and then 5x's here, altogether I have 6x's. 6x is equal to 180 degrees. We're going to divide both sides by 6, and we get that x is equal to 30. We're not done. What we need to do now is find the measure of each angle. If this one's 30, we can do some subtraction and figure out that we got 150 over here. Or we can remember that y is equal to 5 times x. So 5 times 30, again, gives us 150 degrees. And that's what we got. Make sure this makes sense. Don't just copy it down and think that since you copied it, you did a great job. You do a great job, meaning when you teach yourself and you make sure that it makes sense. And if it doesn't, ask me some questions. Hey, I look forward to seeing you soon. Take care.